I'm going to show you how to detect deadlocks using Thread Validator. First, click the rocket icon. Click Browse and browse to the application you wish to profile. Click Launch. Instrumentation process is shown on the top left, and after a few seconds your application is running. The Summary tab shows you high-level information in each of the panels for threads, locks, contentions, recursions, waits, errors, and thread coverage if you have thread coverage enabled. Clicking any bar that's in a panel will take you to detailed statistics about the topic referenced by the bar description. Moving to the Locks tab, if I create a 3-thread deadlock so we have something to work with. This shows you information about every lock, mutex, semaphore, wait happening in the application. Locks per thread shows you the same information, but it's ordered by thread. So there's a thread here and 2 critical sections for that thread. Another thread here, 2 critical sections for that thread. This next thread has quite a few critical sections, and so on. Go to active locks. It just shows you the information about the active locks and active waits in the application. All of the columns on these are sortable, and there is a very useful context menu on every single one. We'll come to that later. On the Wait Chains tab, we have information about each chain of related locks and waits. In this example, we can see some wait chains which are some deadlocks, and there's 3 threads here. They're all deadlocked, and they're all related and completely seized up, as you can see. You can see there's some other threads here which are still running quite happily. If we go to the Threads tab, we've got the historical high-level view of each thread. The orange is contained, the green is just running on its own, and red is a serious problem. So I click the orange there. We can see which locks and threads are involved in that. Click on the lock order and we can see the order of the events there. Click on one of the red tabs and you can see other squares have been highlighted as well. That's because they're all related to this. Go down to the locks and we've got, again, more information about which lock and context menu for that. Go to the lock order tab and you can see the actual order that these locks are required in. We've got the sequence information there, the graphical indication. And when you click on a particular item, if there's a related item, that's also highlighted. So you can see here these 2 items are related to this item here. And on the right hand side, the source code related to each entry is shown. Go on the Analysis tab and Query. We can ask for all sorts of information about what items are locked, what are waiting, what have been abandoned, none in this, what have been deadlocked. Any potential deadlocks, none in this application because we haven't enabled it. Any badlock strategy, none in this application. Any miscellaneous errors, none in this session. Go to coverage, and here we can see synchronization coverage for your application. So basically it's code coverage, but only for the synchronization primitives that have been called by your application. So we're not concerning ourselves with whether functions have been visited or lines have been visited or branch coverage, nothing like that. We're only concerned with, have you actually executed these synchronization primitives? Because if you haven't, there's a chance that your unit tests aren't executing every lock or wait or whatever in your application. Go to active locks, refresh that. You can see where everything was actually created. So here we've got a find first change notification for when a directory contents are changed. Object handles, these are all the handles opened by the kernel in your application. You don't need this information very often, but occasionally it's very useful to have on hand. I go back to the Locks tab, Active Locks. We need to find out why this application is deadlocked. So if I right click on here and choose Show Lock Call Stack, and expand that, we can see sect 3b and sect 3c. So most likely that other one there is the lock for sect 3c because they're both on the same thread. Do the same for the next thread. Go down, lock call stack, expand that one. Lock 3a and lock 3b, different order. And go down again, do that for the next thread, lock call stack, and have a look at that. And what have we got there? lock 3C and lock 3A. Now this is why the program's deadlocked, because the locking strategy isn't the same. I mean, over here we've got A followed by B, that makes sense. And here we've got B followed by C, that makes sense. But here we've got C followed by A, no. That would need to be A followed by C, or maybe even not those particular locks at all. But that's why this program's died. So now you know that information, you can go and change it and fix the application. Thread Validator, quick and easy deadlock detection. Thank you very much.